I realize I have a challenge because I'm the last speaker, I think, before lunch. So hopefully I'll keep your attention. And thanks to the organization for inviting me here to give a presentation about lightweight related to 3M and our solution. So in the next 15 minutes, I will specifically zoom in on some of the challenges, of course, that we discussed this morning, and the solutions 3M has to offer in this space. I guess this is the word, right? Okay, so let me first introduce 3M to you. For those who are not familiar with the company, we're a US-based company existing almost or over 100 years already. And we are based in the US, but most of our sales is actually global. It's outside of the US. We have subsidiaries in most countries around the world, and we have manufacturing facilities also in all of the continents around the globe to just be close to our customers, including here in Turkey. We have a subsidiary, and we have a huge manufacturing hub here as well. So, but in essence, we're a technology company. You might know us from a lot of products, but actually, if you boil it down to the core, we have about 46 core technologies that we use to manufacture more than 55,000 different products. And we sell those in the different areas that you see on the right-hand side of this slide, in the different segments. And definitely also one of them is the transportation industry, and lightweight definitely is a link to that, and I will discuss that, of course, today. We have an objective that says that at least 40% of our sales globally should come from products that didn't exist 5 years ago. Now, given the $30 billion sales that we have, that's quite substantial. That's quite a challenge. That means that we have to invest a lot in R&D, and we're doing that every year. And every year we bring out more than 1,000 new products on the market. And if you look at our vision, we like to bring our products, our technologies, and our innovation strength to improve every home, every life, and every company around the globe. So let's talk about lightweight, because that also is about improving the life of people. It's about CO2, a reduction of CO2 emissions. It's about the megatrends that you see here on the left side that really is driving the lightweight trend. It's really looking into the future and making the future more healthy and safer for next generations to come. We talked this morning already about the automotive industry and the targets that are being set to drive CO2 emissions down. There's a global agreement on driving these down. Currently, the target is set to be an average 130 grams per kilometer for each OEM, so on average for every car that's being sold. That is going to go down to 95, and this morning it was already said that this is really a big challenge for the industry to achieve already. But there is already talks about decreasing that target even further in 2025. This is not agreed yet, but numbers that are showing up is already saying it should go down to 75. Now, how will this be achieved? Just as an example, in this slide on the right, there's been a market study saying that coming from 2012, where the average emission in Europe was 141 grams per kilometer for every car sold that year, going down to 95 in 2020, most of that will be achieved by introducing more efficient powertrains, so more efficient combustion engines. But a part of that will also be achieved by reducing the weight of the car. Could be by smaller cars, but especially also by using lighter materials. And the 7 grams that's given in this example equals about 100 kilograms of weight that needs to be taken out of the car. And another 7 grams needs to come from electrification, so selling more electrical cars. Now, this is up till a target of 2020. Again, that's already a challenge. What's beyond that phase, that's even more challenging. So the industry is definitely looking for solutions and focusing on the target already beyond that point. And definitely it's expected that there will be a lot more push on lightweight materials and a lot more on electrification, so selling more electrical cars in the mix of an OEM. Now, if you look at the solutions that 3M currently has already, that is linked to lightweight and which enables really the use of lightweight materials in the transportation industry, it's already quite various. If you see this, there's a whole palette of solutions. And unfortunately, I'm not able to talk about all the solutions that we have because I only have 15 minutes. So I will zoom in on some of the solutions that we have specifically related to the plastics industry and the plastic parts that are being used. But if you can see on this slide as well, if you are using all of our solutions today in a car, in an average car, we would be able to enable weight reduction up to close to 200 kilograms of a car. So no, unfortunately, that's work in progress. No OEM is using all of our solutions, but that's also, of course, the reason why we give these kind of representation as well. Now, one of the examples, also linked to the plastic industry, has to do with what is called multi-material bonding. There is a huge increase in the use of lightweight materials in cars. It's expected by 2030 that about 70% of a car will be made out of lightweight materials. And this has grown dramatically from 2010 on in the example on the chart. It means there will be a mix of materials being used. Aluminum will be used, magnesium, composites, high-strength steel, for instance, and definitely also plastics. So it will be a combination of that. That means also that it will not be possible to weld all of the, or join all these materials together in a conventional welding method like it used to be in the last century. You need to find newer, more modern joining techniques, and adhesives is definitely one of them. So cars in future will be, say, glued together more frequently, like they have been doing actually for many years already in the aircraft industry. And 3M has a lot of experience in that field. So, but still it's kind of uncomfortable for the industry to talk about this future with adhesives. But as you can see on the slide, we do have a range already of a lot of solutions in the area of tapes and adhesives. Even the most difficult materials can be joined together but with the use of adhesives, like for instance TPOs or even lubricated, so greasy materials, greasy surfaces we can bond together with adhesives. Some other areas that we have solutions in. If you use lightweight materials for vehicles, it automatically means that the noise inside the cabin will increase. Now you have NVH requirements, noise, vibration and harshness requirements that the industry is asking, and of course as a passenger you want to have comfort in your car or in your vehicle. Therefore you need to compensate that with acoustic materials. So more materials actually going in there to absorb the noise coming from the outside and from resonance in the materials. Now 3M has a material called Tinsolate, 3M Tinsolate. It's a non-woven polypropylene material that's already being used in the car industry quite often to reduce the noise inside the vehicle. You might know the Tinsolate material from as a thermal insulator actually in hand gloves in the wintertime, but it also has a lot of acoustic properties, so that's why it's being used also in this industry. It also is very compressible, so you can use it and fill up little voids wherever you're going to use it in a car, for instance, in the inside of a door, for instance. It fills up all the cavities that you have in there, and it doesn't build any mold in the material, so it's not fungus or whatever. It can withstand humidity as well. In the middle part, we're talking about 3M matrix resin. This is a nano-silica-based resin that's lighter, stronger, and more durable than most of the matrix resins that are out on the market to make composites. And in the last couple of years, this matrix resin has been used to manufacture so-called compressed natural gas tanks for the truck market. They have a truck market in the US, so that was the main application where we used it for. We're currently actually working with a big aircraft engine builder here in Europe to develop a lighter weight or lightweight engine for the aircraft industry. And our matrix resin is going to be used to make composite fan blades and composite, or the fan case actually, where the fan blades are in. So this is really high end of the market, but there are also companies actually focusing on making complete composite engines already for cars. So this is also a development that you will see going forward. And of course you need very strong, very good resins for that. And on the right-hand side, we're talking about cooling fillers, boron nitride cooling fillers. Why is that lightweight? Actually, if you use cooling fillers like this in a plastic material, in a polymer, you will make it more thermal acoustic, thermal insulative, and also it can work as an electrically conductor. That means that you can replace metal parts. For instance, in an engine where you need these features, you can replace it with a polymer. So also, again, that's a lightweight solution there as well. And that actually, that particular product is being used in a big project that we're doing, in fact, in Germany with a big manufacturer and supplier to the automotive industry. We're working on a car battery, and this material is being used in the plastic housing of that battery as well. And the last example that I want to give, the last solution, is about 3M glass bubbles. And it's funny, if you look at the picture this morning, I was looking around, and actually it seems like there are glass bubbles all over the place here, because it seems that they are the same as the lights here. But actually they look like that if you put them under a microscope. It's one of the 3 ways to make plastic material, plastic parts lighter. You can do that with thin walling, you can do it with foaming, which was mentioned already in the previous presentation, and you can do it with the use of glass bubbles, so using a lightweight filler, because that's what it is. So I will give you a little bit of an example, or a little bit of insight what it technically is and what it does, and then I will give you some examples where it's being used, because it's quite new actually. And I think it's important that you understand what the applications are. So if you put it under a microscope, in fact, it looks like, if you look at it like this, it looks like a powder. If you put it on a microscope, there are very tiny particles that are hollow, that are spherical, with an aspect ratio of 1, and they're made of glass. So those are the 3 main features of this material. Now, the fact that it's hollow means that the density is very low. We have different versions, but the lowest version is 0.12 grams per cubic centimeter, which is quite low. That also means that you have low thermal conductivity if you use that filler in a plastic material, and also low acoustic transmittance in the material as well. The fact that it is spherical, that it is round, means that the dimensional stability is improving versus normal fillers, and there is less warpage and less shrinkage in the material if you apply that. And then the third feature is that it is made out of glass. Borosilicate glass is used for that, meaning that the material is water and chemical resistant. Now, we have a full range of solutions, so different dimensions, different pressure resistances, and different densities as well. So for every application, we have a type of glass bubbles here. Now, where can it be used? We're actually already for many years using it as a lightweight filler in underbody coatings for cars, for instance. So that's a kind of a liquid or a paste application. You can use it in sheet molded compound applications, like in bumpers, for instance. And the biggest one, actually, the biggest opportunity, as we see, is in injection molding parts. Now, that's quite new for us, because the latest bubble that we have introduced is, in fact, focusing on this application, because we believe this is the biggest opportunity. The benefit, if you talk to a molder, for instance, the benefit of using glass bubbles over, for instance, the foaming technology, is that you don't have to invest in equipment, in tooling or whatever. You can use your existing equipment. We are selling those products into a compounder. The compounder makes a lightweight compound out of it based on the specifications of the OEM, and eventually the molder will use that lightweight compound with the existing machines. The other benefit actually for the molder will be that the cycle time is going up. There's a better flow with the lightweight compound. Therefore, also with serial productions, larger serial productions, there's also a cost benefit from that area, from that point of view. Then to close it off, some examples. Where are we using it? Already for, I think, about 5 years now. They're using it at the Hyundai plant in Korea for a lot of their car models. In different parts in their cars. So the examples that are shown here, just 3 of them, but there are many more examples. An example of a hand glove that you see here, the interior trim part, and also a middle console where it's being used. A very recent one that we're very glad to have is this one. This is a new model, the Alfa Romeo Stelvio, which is just introduced a couple of weeks ago on a car show. It's having glass bubbles in their main dashboard, in the big dashboard. So it's the first injection molding serial production that's going to be in cars in Europe that we have. So we're very glad with that, because the industry is very demanding. But still, as you can see, and we were actually surprised about that. We always claim that you can go up to a weight reduction of about 30% with glass bubbles and still meeting mechanical properties. They achieve 33%. So a real achievement. You can also use the glass bubbles in thermoset applications, like for instance here with the Airbus A350, where some of the parts of the armrest are filled with glass bubbles. They managed to reduce the weight there with about 12%, which translates actually in a fuel consumption reduction of about 1,000 liters per year of kerosene for one of the planes. Now, over the lifetime of a plane, if you take it 15 years and you would look at the whole fleet of 150 planes, this is a reduction of 2.2 million liters of kerosene, specifically only for this platform, for this aerospace platform. So again, you can imagine this is only 5 kilograms taken out of that plane with that application. If you would have applications in all of the plastic parts, let's say in a plane, then the saving would be even bigger. And we're working on that, of course. This is also quite a recent one, introduced in the first quarter of this year. The rear bumper of this Porsche model actually is using glass bubbles now. They already had a lightweight bumper previously, but they still managed to reduce the weight of this bumper with 23% by using glass bubble material. So a very good achievement, because the density is now for the first time below 1, actually. So it's 0.9, which is quite an achievement. And they're going to spread it now, replicate it over other models as well within that company. And also, like I said earlier, in sheet molded compound applications is being used in this particular example with Mercedes and BMW already for a couple of years in this sheet molding compound application. And the last one I want to show is to do with a structural foam that's been used in stiffeners that are being used in cars as well. And you can see where it's being used. Already a program that's going on for about 4 or 5 years. So it's not an injection molding application, but again also a thermoset application. So for many applications you can use glass bubbles, and there is a specific glass bubble for each of the different applications. So I think with that, I hand it over to the next speaker. Oh no, there's no spotter speaker. Thank you.